Graphing a relationship on the coordinate plane is really just a matter of taking one value from one direction and another value from the other direction and seeing how they relate to each other. In example A, they're talking about a situation where you read 20 pages per hour, which means that if you've read for 1 hour, then you've read 20 pages. If you've read for 2 hours, you read for 40 pages, and so on. If we look at this as a function, comparing the number of hours to the number of pages, then we can plot a point at each of these relationships and get an overall view of what happens as you read. The first point we'd have would be 1 hour related to 20 pages. So we'd go over 1 on our hours axis and up 20 on our pages axis, and we get this point that's plotted there on the chart. If we were to go on to the next one, 2 hours would represent 40 pages, and 3 hours would represent 60 pages, and so on and so forth. Now, because we wouldn't necessarily read exactly 1 hour or 2 hours or anything along the way, we might read half of an hour or 45 minutes. We could go along and plot all those individual points, but that would be a little silly. We'd end up plotting, well, really eventually infinite number of points. So what we do is we start at 0 hours and we draw a line that represents all of the possible times in between that we could have read and all the number of pages that we would have read during those times. And that's what this line represents. Okay, in example C, we're actually just going to be graphing an equation. The story that goes along with it talks about how Ali was given a trick by his friend for dealing with numbers, and he wrote the trick down in the form of an equation. So it's the equation that really matters to us here. We have y equals 2x plus 5. And what we're going to do is make a table of values where we substitute a value in for x and then run it through the equation and see what happens, what number comes out on the other end for y. So let's start with x is 0, and then we'll just do 1, 2, and 3. So when x is 0, we get 2 times 0. You can see we substituted it in there, plus 5. 2 times 0 is 0, plus 5 is 5. When x is 1, we get 2 times 1 plus 5, so that's 7. When x is 2, we get 2 times 2, that's 4, plus 5 is 9. And then when x is 3, we get 2 times 3, that's 6, plus 5 is 11. So we have this set of values here, 0, 1, 2, 3, 5, 7, 9, and 11 for x and y. And if we graph those, we can actually, let me move this over real quick. Move this over here to the side so it's out of our way. And then if we graph these here, we can see, get rid of this other one, sorry. Get rid of these little lines here. We can see that the points 0 and 5 are graphed here, and 1 and 7 are graphed here, and 2 and 9, and 3 and 11. So then this line represents all the values that we would get when we combined x and y using the formula that Ali's friend gave him. Any number we put in for x would result in the value that's on the same line where it intersects with y. So if you were to plug 4 in, then for instance he would come out with, looks like 13 over here on this other line. So 4 into that equation would turn out 13 for y when 4 was substituted in for x.